Good day everyone. Today we'll be discussing the topic velocity time graph. Velocity time graph. A velocity time graph, often called a VT graph, is a visual representation of how an object's velocity changes over a specific period of time. In this graph, time is typically plotted on the horizontal axis, that's the x-axis, and velocity is plotted on the vertical axis, the y-axis. We have an example of a velocity time graph of a cycling journey with each of the different parameters and places labeled. As you can see, our horizontal axis is our time and our vertical axis is our velocity. Now, a upward slope gives us our acceleration, a uniform straight line gives us our uniform velocity or constant velocity, while a downward slope indicates deceleration. Now, for a velocity time graph, the area under the curve or under the graph gives us the entire distance of the journey. In this case, we have a trapezium, so the distance of our journey would be the area of said trapezium. Now, we also have the different aspects highlighted separately for clarity. For constant acceleration, we have a vast slope that goes upward. For constant positive acceleration that isn't from the origin, the slope starts from the point of velocity, so it can be anywhere on the vertical axis. For constant positive velocity, we have a straight line, while for constant deceleration or constant negative acceleration, we have a slope that goes downward. So when plotting our velocity time graph, we take all this into cognizance. Now we have our example 1, which states that a train accelerates from rest at 0.5 meter per second square for 40 seconds, maintains a constant speed for 200 seconds, and then decelerates to rest in 20 seconds. What is the total distance traveled? Now, to plot our graph, we are going to start with labeling our vertical and horizontal axis. We have V and T. Then the very first part of our journey states that the body accelerates from rest, which means we are starting from rest for 40 seconds. So we have a slope going upwards, and we can actually mark our V and our 40 seconds. This is a free hand at any place that we like. So when we do that, we will now indicate 40 seconds on the horizontal level and velocity on the vertical level, since we are not giving the velocity. Now it maintains a constant speed for 200 seconds. Now we are going to continue this speed, that is very straight line. This is a constant speed for another 200 seconds, which will make our total time now to be 200 plus 40, which is 240 seconds, and then decelerate to rest in 20 seconds, so which means a downward slope, which will make our total time to be 240 plus 20, which is 260 seconds. Now for our solving, first we find the final velocity V, because we were not given that our final velocity for the initial part of the motion. Now V is equal to U plus AT for our equation of motion, and we know our U is 0 because we are starting from rest. A is equal to 0.5 meter per second square, and the T for the first part of the journey is 40 seconds. So substituting this, V will be equal to 0 plus 0.5 multiplying 40, or 40 in bracket, which will make V to be equal to 20 meter per second. Now we've gotten the value for V. Now the next part is to look for our distance, and as we know, the area of the trapezium will be our distance, which is 1 over 2a plus b times h. From our plot, our a is equals to 200, our b is equals to 260, that's the entire time, and our h will be the velocity, or our final velocity, which is 20. Substituting this, our distance will be equals to 1 over 2 in bracket 200 plus 260 times 20, which will be equals to 1 over 2 in bracket 460 times 20, which will be equals to 4,600 meter. Our second example states that an object starts from rest and accelerates uniformly to V in 10 seconds. It then travels at V for 30 seconds before stopping in 5 seconds. If the total distance is 225 meters, what is V? Now plotting our graph, noting our vertical and horizontal axis V and T. The first part states that it starts from rest and accelerates for 10 seconds. So indicating that on our graph, we get V and 10 seconds. Then the next part, it continues at this velocity for 30 seconds. Now plotting that, we use a horizontal line, and we get, so our total time will now be 40 seconds, which is 10 plus the 30, which is 40 seconds. Then it decelerates or comes to rest in another 5 seconds, so we have a downward slope, which will bring our total time to 10 plus 40 plus 5, 10 plus 30 plus 5 rather, which is 45 seconds. Now for distance, we know that our distance will be the area of the shape on, so s will be equals to half a plus b times h. A is equals to 30, as you can see, b is equals to 45, and h is equals to v, which is equals to unknown, and our s is equals to 225. And since we are looking for v, substituting this into the equation, 225 will be equals to 1 over 2 in bracket 30 plus 45 times h, which becomes 225 is equals to 75 over 2h. Cross multiplying, 75 times h should be equals to 225 times 2, which makes 75h should be equals to 450. Dividing both sides by 75, h should be equals to 6. So our velocity v will also be equals to 6. We have another example that states that a sprinter accelerates from rest to 12 meters per second in 4 seconds and maintains this speed for the remainder of a 100-meter race. What is the total time taken for the race? Now in this case, we are looking for our time. So plotting our velocity time graph, we have our horizontal and our vertical axis, which are time and our velocity. Now plotting the first part, it said it accelerates from rest at 12 meters per second, so it's an upward slope upwards to 12 meters and 4 seconds. Then it continues at this speed for another 100 meters, for a total of 100 meters. So it just be a straight line. Since we are not told it comes to rest and any other details, you are going just to end it at with a broken line, and we were told that the entire journey was 100 meters. So we know that the area under the curve is our distance, and our outside distance is 100 meters. S is equals to 1 over 2a plus b times h. That's the area of a trapezium, or this trapezium. And we know that a is equals to t minus 4, because we know that the entire journey is t and the first part is 4, so the up will be t minus 4. B will be equals to t, and h will be equals to 12. We know that s is equals to 100. So substituting this into the original equation, it becomes 100 is equals to 1 over 2 in bracket t minus 4 plus t in bracket times 12. Simplifying the bracket, it becomes 100 is equals to 1 over 2 in bracket 2t minus 4 times 12. And dividing 12 by 2, it becomes 100 is equals to 6 into 2t minus 4. Expanding our bracket, we get 100 is equals to 12t minus 24, which will make 100 plus 24 is to be equals to 12t, and dividing both sides by 12, we have 124 over 12 will be equals to 12t over 12, which will make t to be equals to 10.33 seconds. We have our final example that states that two cyclists A and B start together. A travels at a constant velocity of 8 meters per second. B starts from rest and accelerates at 2 meters per second, which is also the same as 2 meters per second square. At what time will B have covered the same distance as A? For our solution, we'll be plotting both motion in the same velocity time graph. Now, for A starts at 8 meters per second and maintain a constant velocity. So it should just be a straight line from 8 meters per second on the velocity axis. While B starts from rest and accelerates for 2 meters per second square to the same time t, but we're not given the final velocity of B, so we're going to be calling that VB. Now our first step is we are going to find the velocity of B, which is VB will be equals to U plus AT, which will make VB to be equals to U multiplying T, which will make VP to be equals to 2T. For A, our total distance covered by A will be equals to the area of the rectangle, which will be equals to 8 times T, which will be equals to 8T. While for B, the distance will be equals to the area of a triangle, which is half base times height, which will be equals to 1 over 2 times t square, which should be equals to times 2t rather, which should be equals to t square. Now, since both cyclists cover the same distance, t square will be equals to 8t. That we're going to equate both distance together. Dividing both sides by t T square over t will be equals to 8t over t, which will make t to be equals to 8. So the total time for the journey was 8 seconds. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out our Hidden Facts Physics textbook. You can get the hard copy in bookshops, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen. Thank you.